been talking about these models that were trained to predict each mental condition independently. However, many of these conditions that they're trying to predict are comorbid with each other. They tend to co-occur. So in order to exploit these co-occurrences, we decided to train a model to jointly predict all mental conditions at the same time, rather than independently. And hopefully we can train learning classifiers that predict each of the mental conditions better than independently trained models. So the simplest set of models you could think of would be to train n independent logistic regression models, where n are the number of conditions you're trying to predict. What we proposed to do and what we did was to test this in a multi-pass framework where we have a feed-forward neural network, and for each user we tried to predict every single mental condition that they claim to be diagnosed with at the same time. And each of these models shares parameters in the first linear. So here's a ROC curve of trying to predict whether or not someone's at risk of attempting suicide. The pink curve corresponds to our multitask model, and the gray curve corresponds to just the baseline independently trained model. And you can see the pink curve's higher. That's better for ROC curves. And we see this for just about all the mental conditions we predict, where the multitask model outperforms the baseline statistic regression. However, it's difficult to look at all of these ROC curves simultaneously, so we can just look at the area under the curve for each of them. You can see here that we do consistently better, except in the case of predicting the gender of a person, and that has to do with the fact that not all of our users were annotated with gender. So when we were training this joint model, it wasn't learning a representation that was necessarily as predictive of gender as it was for the other mental conditions. So in that case, training independent models was better. So at this point, we asked ourselves, there were two likely explanations for why we're seeing these gains. One explanation is that we're just training a deeper network and we're performing some sort of dimensionality projection, and we can generalize better down some examples. Another explanation is that the multitask training is helping us, and that learning representations that are predictive of depression are also useful for predicting whether someone's anxious or not. So to tease these apart, we decided to go deeper. So the question we asked ourselves at this point, that's the face I made. Right, so all we did is we took these baseline logistic regression models and we extended them to feed-forward neural networks. So each of these networks has the same number of parameters, the same architecture as one path in our multipath model, from input features to predicting a single mental condition. And when we evaluate this model, these are the light blue bars, it becomes less clear if we're seeing much gain from training the multitask center. So the conditions towards the right tend to have more positive examples in them. There we tend to see that multitask training helps us, gives us a slight boost, although is only for anxiety and depression, I believe, that those differences are statistically significant. And for the cases where we have fewer positive examples, it seems like training an independent model actually can be pretty well better. So that is where we're at.
But you can predict the gender now.
Yeah, we do better at gender. So this sort of confirms our hypothesis that perhaps training these things jointly and not having as many gender annotations was actually hurting us for that particular test. So we can train a better independent model on that. And above is just the average AUC for each of these models. The multi-test model ekes by. And like Andreas mentioned, this seems to suggest that the multi-test training is hardiness for cases where we don't have any patients for each and every person. So our hope, or our next step in training this model was to hopefully apply it frame by frame for a month at a time, so we could infer how depressive or anxious the language of a person was for a given time period, and then use these estimates to predict whether or not someone is at risk of attempting suicide, given our data. This is a clear next step, and with that, I'll hand it over.